Dear students, welcome to our science episodes. Today we are going to discuss oscillatory motion. Oscillatory motion. What is motion? Motion is known to be the change in position of an object over time. Types of motion. We have transitional motion and periodic motion. What is periodic motion? It is the motion that is regularly repeated in equal periods of time. Periodic motion could be oscillatory motion or wave motion. Today we are going to discuss oscillatory motion. Here is an activity. We're going to use a pencil, a 30 centimeter long thread, and a metallic piece with a hole. Set up a simple pendulum, like in the picture, by winding one of the thread ends at the middle of the pencil. The other end is attached to a metallic piece, which is the oscillating body. Grab the pencil with your left hand and put the metallic piece to the right and let it go. What will be the observation? The oscillating body is repeatedly moving around a point of rest. And the periodic motion made by the oscillating around its point of rest, where the motion is repeated through equal intervals of time, is known as the oscillatory motion. If you look to this picture, you can see the point of rest is at the center or in the middle. And this simple pendulum is moving right and left, right and left. This is a repeated motion around a point of rest. Whenever you find this type of motion, it is called oscillatory motion. In this diagram, here is a simple pendulum. Of course, B is the point of rest, and this oscillatory object is moving to the left and to the right. To the left till point A, and then to the right till point C. Like this, from A, B to C, and from C, B again to A. Knowing that B is the rest point, BC, this distance, or AB, BC, or AB are the displacement. And the displacement on either sides is equal. So this means that AB is equal to BC. The velocity of the oscillating body is the maximum at the point of rest. So at which point the velocity is maximum? At the point B. The velocity of the oscillating body decreases as it moves away from the point of rest until it becomes zero at the maximum displacement on either side. Let's explain it on the diagram. At point B, the velocity is maximum. Then the pendulum or the oscillating object will move to the point C. As it moves to the point C, its velocity decreases until it is zero here. And then returning back to point B, maximum velocity. And then the velocity will decrease again and again until it becomes zero at the point A. And then back to the point B, and so on. Did you ever wonder about the relation of the velocity of the pendulum and its kinetic energy? Let's see together. Kinetic energy is known to be equal to half of the mass multiplied by velocity to the power 2. So here is the equation or the formula. Kinetic energy equal half mv square. Kinetic energy of the pendulum is directly proportional to its mass and square of its velocity. It is known that the kinetic energy of the pendulum will increase when the mass will increase or when the speed will increase. And this, of course, makes sense. In the following pendulum, at which position the displacement is maximum? Of course, it's position 1 and 3. At which position the velocity is maximum? It's position 2, the point of rest. What happens to the kinetic energy of the pendulum at position 3? Velocity is 0, and accordingly, the kinetic energy is minimum. This is a graphical representation of oscillatory motion activity. We are going to use a paper tape winding around 2 rolls. We are going to use a weight. This is the weight. And this is a paper tape winding around 2 rolls. A spring. This is the spring. A nail and a pencil. We're going to attach the pencil to the weight and hang the weight to the end of the spring. We will hang the other end of the spring with a nail to the wall. So we will fix this spring to the wall to make the pencil tip touch the paper roll. Pull the spring downward. We are going to pull it downward and then let it go. You will find that the pencil will draw a graph on the paper representing the simple harmonic oscillatory motion of the spring, exactly like you see in this picture. Here is the movement of the spring when you will pull it down and then let it go. And the graph representing the simple harmonic motion is considered to be the simplest form of oscillatory motion, as you will see in this graph. Now, identify which picture represents oscillatory motion. This is a tuning fork, and this is a stretched string of a guitar, a swing, and this is a spinning top. All of them represent oscillatory motion except the spinning top. Why? Because a spinning top motion is periodic because it is repeated, but it's not oscillatory because it's not repeated around a point of rest. If you will watch these types of motion, you will find them repeated on or around a point of rest, but the spinning top is not. Now these concepts are related to the oscillatory motion: amplitude, complete oscillation, periodic time, and frequency. And we are going to discuss amplitude now. Simply, amplitude is the maximum displacement. So it is at point C and at point B. And we also know that the value of A, B, and AC are equal. So the maximum displacement achieved by an oscillating body away from its point of rest is called the amplitude. So this means that AB is an amplitude and AC is another amplitude, and they are equal. Here we go. If we want to draw a graph for this wave or this oscillatory motion, you will find that from point A, B is an amplitude, B A is another amplitude. A, C is an amplitude, and from C, A is another amplitude. It is the maximum displacement achieved by the oscillating body. And it is measured in meter. Now, in which graph the amplitude is bigger? We have graph 1 and graph 2. In graph 1, the amplitude is bigger than graph 2. It's obvious that the wave is moving away from the point of rest more than in graph 2. What is meant by the amplitude of a simple pendulum is 4 centimeters. This means that the maximum displacement made by a simple pendulum is 4 centimeters, or in another word, 0.04 meter. What is meant by the maximum displacement made by an oscillating body is 6 centimeters. This means that the amplitude of the oscillating body is 6 centimeters, which is equal to 0.06 meter. Now it's time for questions. Write the scientific term. Motion that is regularly repeated in equal periods of time. Periodic motion. The simplest form of periodic motion. Simple harmonic motion. Maximum displacement achieved by an oscillating body away from its point of rest. Amplitude. Now, can you think about the motion of planets around the sun? This is considered to be periodic motion, but non-oscillatory motion. Can you think why? This is because they move in regular repeated motion. The motion is regular and repeated in equal periods of time. That's why it is periodic motion. However, the motion is not repeated around a point of rest. That's why it's non-oscillating. Now, what is the amplitude in this pendulum? Remember that this is the point of rest, point A, and then the pendulum is moving from A to B and again from B to C. From A to B, it's 2 meters, and from A to C, it's 4 meters. So the amplitude is 4 meters, as C is the maximum distance the oscillating body is traveling from the point of rest. Thank you. Dear students, thank you for watching. See you later in other science episodes.